Hello friends, welcome to Input Output Campus. So from today we are going to start a new series, that is top 100 coding question for placement. And believe me guys, this series is going to be awesome for you, because in this series you will learn many more things and many new concepts and many new questions. We'll solve it in a very simple way. Okay, so I will try to explain you the each and every question in a very simple way. Okay friends, so before starting the video, make sure you have subscribed to this channel and press the bell icon, so when I will upload a new video you will get the notification bar. And after watching the video, please hit the like button and share it with your friends. So after sharing the video with your friends, discuss the problem with your friends. So by discussing the problem more and more times, you can feel more comfortable and confident about the question. Okay, and by doing this you can improve your coding skills. So if you find this video helpful after watching the whole video, then please share it with your friends and your WhatsApp groups also. So today we'll discuss about a parenthesis problem, that is remove the outermost parenthesis. So remove the outermost parenthesis, that means you are giving these inputs, and in the input string there are only first parenthesis and the opening bracket and the closing bracket. Okay, so you have to remove the outermost parenthesis. Red colored parentheses are the outermost parentheses. So you have to remove this red colored parenthesis from this string. So after removing this red colored parenthesis, you can see our output looks like this. Okay, so outermost parenthesis means you have some parenthesis inside this, and this should be like this, and you have to remove this outermost parenthesis. Okay, so now how can we solve this problem? So see here friends, so the ASCII value of the opening bracket and the closing bracket of this first parenthesis, that is the ASCII value for this opening bracket is 40. Okay, and for this closing bracket the ASCII value is 41. Okay, so using this ASCII value we can solve this question very easily. So you can see these types of question in the competitive exam. This question is important for your competitive exams. Okay, to solve this question, we'll write a for loop and iterate to this string, that is from first to last, and using this for loop, inside this for loop we'll check using if condition, if the first character is 40 or 41. Okay, if this is 40 then it is the opening bracket, and if this is 41 that means this is closing bracket, and if it is the outermost parenthesis then we will ignore it. Okay, we will not store it. So if it is the innermost parenthesis then we will store it. Okay, so hope you understand the question. So now we'll write the code. So first write the basic format of the C++, that is as include iostream using namespace standard. Okay, so write here int main, and inside the main function we have to write the string. Suppose string is, and a string was this, so let's copy this and paste it here. Now write a function. Suppose the name of the function is remove parenthesis. Okay, or remove p. Okay, so inside this function pass this string. Okay, so now write the same function here, that is remove parenthesis, and what will be the return type? So return type will not be integer. Why the return type will not be integer? Here you can see it returns a string also, so our return type will be string here. So we will return a string from this function, so for that write here string. Okay, so inside this function write the same string, that is string s. Okay, and now write an empty string where we will store the result and return the result as a string. So for that write here string result equals to empty. Okay, so now write a for loop and we'll iterate the string from this first to last. So for that write a for int I equals to 0, I less than s dot size. Okay, I plus plus. So inside this for loop we'll check if s of I, that is if the first character is opening bracket or closing bracket. So if s of I equals to 41, that is if this is a closing bracket, then we'll do operation. So what operation? Suppose there is a integer, suppose int j, and we initialize it with 0. Okay, so if s of I equals to 41, that is if this is the closing bracket, then we'll decrease this value, that is j will be decreased. And next we'll check if j not equals to 0, if j not equals to 0, if j is not 0, that is if j decreased, then we'll store the s of I, that is this character, into this result. So for that write here result plus s of I. So s of I will be stored into the result. Now again we'll check if this is a opening bracket. So for that we'll check here if s of I equals to 40. So if this is opening bracket, then we'll increase the j value. So j value will be increased. Okay, so in this way we'll iterate whole the string and we'll store the character into the result. So let's take this example and let's see if this works fine or not. Here our string is empty, that is our result string is empty, and j value is 0, and we iterate from I equals to 0 to I less than s dot size, that is from this 0 to this last. So our first character here you can see this is opening bracket, that is its ASCII value is 40. Okay, so now we'll check here if s of I equals to 41. No, s of I is not equals to 41. Next we'll check if j not equals to 0. No, j is 0, so this condition not satisfied. Next we'll check the if condition if s of I equals to 40. Yes, s of I equals to 40, that is this is a opening bracket, so s of I equals to 40. So we'll increase the j value, that is our j value increased to 1. So j value was 0 and it increased to 1. So next we'll increase the I value, so I will be 1 and it will check if s of I equals to 41. No, s of I is not equals to 41 because this is the opening bracket. So here you can see this is opening bracket. So if j not equals to 0, yes, j not equals to 0 because j equals to 1 and this is not equals to 0. So we'll store s of I into the result. So this character, this second character, that is this opening bracket, will be stored into the result. That is here this character will be stored. Now we'll check if s of I equals to 40, that is if this is the opening bracket. Yes, this is opening bracket, so j value will be increased. So j value was 1 and it will increase to 2. So j value will be 2. Now our I value will be increased and we'll go to this closing bracket. Okay, this bracket. Now we'll check if s of I equals to 41. Yes, s of I equals to 41. That is s of I is closing bracket here, this bracket. Okay, so for better understanding, let's separate it. Okay, so this bracket. Okay, so j value will be decreased, so j value was 2 and it will decrease to 1. Okay, so next we will check this if condition if j not equals to 0, j equals to 1 and this is not equals to 0, then we will store this s of I into the result. Okay, so s of I equals to this closing bracket and this will be stored into the result. So our result was this and this closing bracket will also be added. Next we will check if s of I equals to 40. No, s of I not equals to 40. Next we will increase the I value and next we will go to this opening bracket. Okay, so this is done and next we are here and the ASCII value of this opening bracket is 40. So now we'll check if s of I equals to 41. No, so if j not equals to 0, yes, j not equals to 0, that is j equals to 1. So we'll store this s of I into the result. So our s of I is this opening bracket and this will be stored into the result. So here will be stored. This bracket will be stored into the result. Now we will check if s of I equals to 40. Yes, s of I is the opening bracket and this is 40. So j will be increased. So j value was 1 and it will increase to 2. So now our I value will be increased and this is done, and we will go to the next character, and our next character is this. Okay, so this is our next character. Okay, and the ASCII value of this is 41. Now we'll check if s of I equals to 41. Yes, s of I equals to 41 because this is a closing bracket and its ASCII value is 41. So now we'll decrease the j value. So j value was 2 and now we'll decrease it. So our j value will be 1. So now we'll check if j not equals to 0. So our j is 1 and j not equals to 0. So we'll store this s of I into the result. So s of I is this closing bracket and this will be stored into the result. So here this will be stored. So now we'll check if s of I equals to 40. No, s of I is not equals to 40. This is 41. Okay, so the I value will be increased. So this is done. And we'll go to this character. The ASCII value of this closing bracket is 41. Okay, now we'll check if s of I equals to 41. Yes, s of I equals to 41. This is 41 and j value will be decreased. So j value was 1 and it will decrease to 0. Okay, now we'll check if j not equals to 0. So our j value is 0. So if 0 not equals to 0, so this is false. Next we'll check this condition if s of I equals to 40. So no, s of I is not equals to 40. This is 41. Because this is closing bracket. Okay, so next we'll increase the I value. Okay, so this is complete and we'll check this. So this is opening bracket and its ASCII value is 40. So now we'll check if s of I equals to 41. No. If j not equals to 0. No, j equals to 0. So next we'll check if s of I equals to 40. So s of I equals to 40. So this is opening bracket and its ASCII value is 40. So s of I equals to 40. So j value will be increased. So j value was 0 and it will increase to 1. Okay, so this is complete and we will increase the I value. Okay, so this is complete and we'll check for the next, that is this opening bracket and its ASCII value is 40. So now we'll check here if s of I equals to 41. No, s of I is not equals to 41. So if j not equals to 0, j equals to 1 and 1 not equals to 0, yes, is satisfied. So s of I will be stored into the result. So this opening bracket will be stored into the result. So here will be the opening bracket. Okay, so now we'll check if s of I equals to 40. Yes, s of I is a opening bracket and this is equals to 40. So j value will be increased. So our j value was 1 and this will increase to 2. Okay, so next we'll increase the I value and this is complete. So next we'll check for this character. Okay, and this is closing bracket and its ASCII value is 41. So now we'll check here if s of I equals to 41. Yes, s of I equals to 41 because here you can see this is 41 and we will decrease the j value. So j value was 2 and it will decrease to 1. Okay, so now we'll check if j not equals to 0. So j equals to 1 and 1 is not equals to 0. So s of I will be stored into the result. That is s of I was this closing bracket and this closing bracket will store into this result. Okay, so here it will be stored. So now we'll check if s of I equals to 40. No, s of I is not equals to 40. This is 41. Okay, so next we'll increase the I value. So this is done. Okay, so we have this closing bracket and its ASCII value is 41. Now we'll check here if s of I equals to 41. Yes, s of I equals to 41. So j value will be decreased. So j value was 1 and it will decrease to 0. Okay, now we'll check if j not equals to 0. So j is 0. So this is not satisfied. So we'll check the if condition if s of I equals to 40. No, s of I is not equals to 40. This is 41 as this is closing bracket. Okay, so we'll increase the I value, that is I value will be increased and it will check if I is less than s of size. So this condition will be false and we'll go outside of this for loop. Okay, so after going outside of this for loop, what we'll do, we'll return this result because we have returned the string into this result string. Okay, so this is our final result and we will return this result to the main function. So here write the return result. So this will return the result and this is a string. So for that we have write a string, it will return a string. So this string will come to here, we'll store it into another string. So for that write here string answer, and this string will come to here and it will store into the string answer. Okay, so we have get the string and now our task is to print this string. So how you will print this string? So for that write a for loop. So for int I equals to 0 and less than answer dot size, answer dot size, then I plus plus. Okay, now print it. So write a cout and then answer of I. So it will print each and every character of the answer. Okay, so our code is complete. So let's run it. So here you can see, okay, so here you can see our input string was like this and this is our output string. So all the outermost string are removed. Okay, so in this way you can remove the outermost string. So this question is very important for your placement and competitive exams. Today in this video we will discuss about a very important coding question, which is occurrence of digits in a range, and this question is very important for your upcoming on-campus and off-campus examination. Okay, so we'll discuss about occurrence of digits in a range. Okay, so suppose you are given a range 1 to 10 and you have to find the occurrence of digits, and which digit? Suppose the digit is 5. So you have to find how many times the 5 appears in this range 1 to 10. So in the range between 1 to 10, 5 appears only 1 times. Okay, so if I say that how many times 5 appears, so this is easy. So 5 appears 2 times. So 5 appears 2 times in this range 1 to 20. So now if I ask you, between this range 1 and 20, how many times 1 appears? So we have to calculate this. So 1 and then 11 and then 12, 13, 14, 15, 16, 17, 18, 19 and 20. So here you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So between this 1 and 20, so digit 1 appears 11 times. So our output will be 11. Okay, so suppose you are given the range 50 to 60. So between this range you have to find the occurrence of digit 5. So then you have to write 50, 51, 52, 53, 54, 55, 56, 57, 58, 59 and then 60. So now count the occurrence of 5. So for 50 this is 1 and then 2, then 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so here the occurrence of 5 in this range is 11. Okay, so this is the question and how you will solve it. Okay, so for that we'll write a for loop and we'll iterate from this range, from this lower range to this upper range using a for loop. And inside this for loop, so we'll take every number from this beginning to this end. Suppose we have take 54. Okay, so we'll do a while loop for this number. So while 54 greater than 0, that is until the 54 not becomes 0, we'll do this while loop, and inside this while loop what we'll do, we'll check the remainder of this 54. So for that we'll check 54 percentile 10. So 54 percentile 10 and the remainder will be 4 and this is not 5. And if this is not 5 then we will not count this. Okay, if this is 5 then only then we will count this. Okay, so after checking this remainder of this number, we'll remove this last digit. Okay, here the last digit of 54 is 4 and we'll remove this 4. So how you will remove this 4? So to remove this 4, we'll divide this by 10. So 54 by 10 and it will give us 5. So again this 5 will come to here and 5 is greater than 0. So again we'll check if 5 percentile 10 equals to 5. Yes, so 5 percentile 10 equals to 5, that is the remainder is 5. Okay, so then we'll increase our count value. So our count will be 1 and then we'll divide this 5 by 10 and this will gives us 0. So here will be 0 greater than 0 and this condition will be false and this while loop will be terminated and our count value will be 1 for this 54. So for this 54 our count value will be 1, that is 5 is present in this 54. So similarly we will do this operation for all of these numbers and we will count the number of digits, that is the occurrence of digits. Okay, so hope you understand this question and how we will solve it. Okay, so let's write the code. So first write the basic format of the C++, that is as include iostream using namespace standard, and then write the main function here. So inside this main function we'll write the lower value. So our lower value is suppose 50 and our upper value is suppose 60 and our digit is suppose 5. Okay, so now let's write a function where we'll calculate this. So this is occurrence function. Okay, so inside this first this lower, then upper and then digit. So pass all of these variables and before this main function write this function again and the return type will be integer because it will return the number of count. So write here int occurrence. Okay, inside this write integer lower, int upper, int digit. Okay, so inside this function write a count variable. Okay, so our initial count value is 0 and after that write a for loop and for int I equals to, so I equals to from this lower to this upper. So I equals to lower, I less than equals to upper and then I plus plus. Okay, so inside this for loop, we'll store every value that is from lower to upper. So we'll store every number into another temp variable because we don't want to disturb that variable. So we will do an operation using while loop. So there the number will be changed. So we don't want to disturb the number, so we will store that into a temp variable. Okay, so for that write here int temp equals to I. So the I value will be stored into the temp. So now we will write a while loop and while this temp is greater than 0. So while this temp is greater than 0, we'll check if its remainder is 5 or not. So if temp percentile 10 equals to 5, no, so equals to digit. So in the digit we have give 5 here, so just check if the remainder is 5 or not. So if it is 5 then we'll increase our count value. So after this we'll remove the last digit from this number. So for that write here temp equals to temp divided by 10. Okay, so after this go outside of this for loop and when the all operations will be done we'll return the count value. So write here return count. Okay, so this will return the count value and we'll print it from here. So write here cout and print the result. Okay, let's run it. Okay, so here you can see our output is 11 and this is perfect because in the range of 50 to 60 there was 11 times 5. So if I change this range, suppose 1 to 20, and we want to find the occurrence of digit 5 in this range. So you know in this range the occurrence of 5 is 2. So for 15 and the other one is for 5. So let's run it. Okay, this is perfect. So our output is 2. Okay, so you can check it by giving another inputs. So here you will be given an input like this 1, 2 and 3 and your output will be 3. So how your output will be 3? So here you can see this is the possible number of decodings. So if you are giving an input like this 1, 2 and 3, so how many ways you can decode this? But you have to remember that here A represent 1 and B represent 2 and so on. Okay. And you know our alphabet is from 1 to 26. So our input, so here the input is given 1, 2 and 3. Okay. So we can write it as 1 and then space and then 2 and then space and then 3. Okay. So here 1 represents A and 2 represents B and 3 represents C. So this will be A, B and C. Okay, this is one way. And next what we can do, we can write this in another way like 1, 2 and then space and then 3. So 1, 2, so in alphabetical order 1, 2, that is 12. So 12 represents L and 3 represents C. So this is another way, and we can also write it as 1 in separately and 2, 3 in separately. Okay. So 1, so you know 1 is for A and 23. So in alphabetical order 23 represents W. So this is the possible way we can decode this 1, 2 and 3. Okay, so our output will be 3. So now let's take another example like 3, 2 and 1. Here we will see the output and here will be. So let's remove this and write here 3, 2 and 1. Okay. So in how many ways we can write this 3, 2 and 1, but we have to remember that the characters are between 1 to 26. Okay, so we can write this as 3 separately and then 2 and this will be separated and then 1. So this is, so 3 represents C and then 2 represents V and then 1 represents A. Okay, this is one way we can decode this, and the next way we can decode this is 3 and then space and then 2, 1. So 3 represents C in alphabetical order and 21 represents U in alphabetical order. Okay, so this is one way to decode this, and we'll check if there is any another way to represent this or to decode this. Okay, so here we can split this as 3, 2 and then 1. But wait, we cannot write this as 3, 2 because this is 32 and in our alphabetical order there are 26 characters. So 1 to 26, but this is out of 26. So we cannot decode this. Okay, so this cannot be decoded. So our possible number of decodings for this 3, 2, 1 will be 2. So our output will be 2 here. Okay, so hope you understand this question. So now what will be our approach to solve this? So our first step will be to calculate the length of the input. So we'll treat 3, 2, 1 as string and the length of this will be 3. So we first will calculate the length. So calculate length. So calculate length of input. And our second step, we'll write an array where we'll store. So let's say its size is n. Okay, so length is n. So next we'll write an array for counting the possible number decodings, and the length of the array will be n plus 1. Okay, because we will store the count of variables from 0 to n. So 0 to not less than n. We will count from 0 to n. So for that we have right here n plus 1. So our next step will be, we will initialize the first and the second position of this array as 0. Okay, so count of 0 will be 1 and count of 1 will be 1. Okay, so these two position will be 1. So we will initialize this 0 position and 1 position as 1. So next we'll write a for loop and we'll iterate from 2 to n. Okay, from 2 to n. So next we'll write a for loop and we'll iterate from 2 to n. And for this position of 2 to n, the count value will be 0. That is for position I, count of I will be 0. So this is the initial step. So now we'll check the every digits of the string. So this is a string and now we'll check every digits. So now we'll check here if the digit of I minus 1 is greater than 0 or not. Okay, so digit of I minus 1. So you can see here, this is the 0 position, so 3 is in the 0 position and 2 is in the 1 position. Okay, and this is the position 2. So this is the ith position. So if this 1 is in the ith position, then this 2 will be in the I minus 1 position and this 3 will be in the I minus 2 position. So now we check here if digit of I minus 1, that is this middle position, that is this 2, if this 2 is greater than 0, if so, we'll store this count of I minus 1. So we'll store this count of I minus 1 into count of I. So our count of I minus 1 was 1. So here you can see, so our I is 2 and I minus 1, that is 2 minus 1, that is 1, count of 1. So you can see here count of 1 is 1 and we'll store it into the count of I, that is count of 2. We'll store this value, this 1 value into this count of 2. Okay, now again we'll check here if digits of I minus 2 is 1, that is, so I minus 2 means that is the first position. Okay, so if this is I position and this will be I minus 1 and this will be I minus 2, if digit of I minus 2 equals to 1 or digit of I minus 2 equals to 2, so if this position, that is I minus 2 position, that is the first position, is 1 or 2 and there is another condition, and digit of I minus 1, so I minus 1 less than 7. So why less than 7? So digit of I minus 1 is less than 7. So digit of I minus 1 is less than 7. So digit of I minus 1 means this position. Okay, if this is less than 7, so why we write here 7? Because there are 26 characters in alphabet. So 1 to 26, so 6 is the largest number. So if this position, so in this position I minus 1 position, so this is less than 7. So it could be 1 to 6, anything, but this must be less than 7. Okay, so if this is less than 7, then we will add this count of I minus 2. So then we will add this count of I minus 2 to this count of I. So to this count of I. Okay. And then we'll store it into this count of I. So in this way we will count the number of possible decodings. Okay. And after go outside of this for loop, we will return this count. So just simply return this count. So hope you understand this. And now let's write the code. So first we'll write the basic format of the C++ and then write the main function here. Okay, inside this main function, write here a character type array. So suppose this is digits and let's say the length of this is 15. Okay, so take the inputs from the user. So now calculate the length of the inputs which user has given. So for that write here intent and insert this string length digits. So now write a function. So suppose the name of the function is decodings. And here first the array and here write digits and then the length n. Okay. So now write here in decodings and insert this write character digits and then integer n. Okay, so now write int count. So the length of the array is n plus 1. So this was our second step. Now we will initialize the first position and the second position of this count array as 1. Okay, so count of 0 equals to 1, count of 1 equals to 1. So now our next step is we'll write a for loop from 2 to n. Okay, so just write here a for loop. So for int I equals to 2, I less than equals to n, and then I plus plus. And inside this for loop, write count of I equals to 0. Okay, we have initialized the count of I as 0. Now we'll check the condition. So first condition was if digits of I minus 1 is greater than 0, then we'll store the count of I minus 1 into count of I. So right here if digits of I minus 1 is greater than 0. So as this is a character, so we have to write it inside this single bracket. Okay. So if digits of I minus 1 is greater than 0, then count of I equals to count of I minus 1. So count of I minus 1 will be stored into the count of I. So next we will check the next condition. That is, our next condition was if digits of I minus 2 is 1 or digits of I minus 2 is 2 and digits of I minus 1 is less than 7, then count of I and the count of I minus 2 will be added to count of I. Okay, so write this condition here. If digits of I minus 2 is equals to 1 or digits of I minus 2 is equals to 2, and there is a condition and there is another condition, that is if digits of I minus 1 is less than 7. Okay, so this condition must be satisfied, that is digits of I minus 2 is equals to 1 or digits of I minus 2 is 2 and digits of I minus 1 is less than 7. Okay, so these two conditions must be satisfied or this single condition must be satisfied. If any of these conditions satisfied, then we'll write here count of I equals to count of I plus count of I minus 2, count of I minus 2. Okay, and after doing the whole of the operations, we'll reach to the end of the array of this count, that is we will reach to count of n because it starts from 0. So count of 0 to count of n, that is count of n plus 1, and final result will be stored into count of n. So we'll return this count of n here. So outside of this for loop, write here return count of n. Okay, so this count of n will be returned from here. And finally we'll print it here, cout, and here include a header file cstring. So let's run this. Okay, it's compiling. So give some input here, suppose 1, 2 and 3, and this is 3. So first we have saw that if the input is 1 to 3, the number of decodings will be 3. So now we'll give some other input like 3 to 1. So for 3 to 1 you can see here, so for 3 to 1 the number of decodings will be 2. Okay, so let's give it here 3 to 1. So you can see here the output is 2. So this is perfect output. So here you can see a snapshot of the question. So here is the question which just came in essential coding test, that is alt tab window. So here you can see the question, whole question, and here you can see the input output specification. Okay, so let's discuss about the question and next we'll write the code. Okay, so here is the question. Given an integer k, so k is an integer and an array of n integers which contains the IDs of the offend apps in a system where A0, where array of 0 is the app currently in use. So array of 0, that is the first element in the array is the currently used app. So here you can see. Okay, so here you can see this is an array and the array includes some elements and these elements are known as IDs. Okay, so in this problem these elements are known as IDs. So array of 0, that is the first element of this array, is the app currently in use. So if you are using laptop or computer or any phone, okay, so if you are using some apps, suppose this is the name of the apps, so 3 is the name of the apps and A of 0, that is this apps is the app currently in use. Okay, and A of 1 and array of 1, that is the 5. So this is the ID of the app and you can see that this is the name of the app. Okay, so array of 1 is the app which was most recently used, that is you have used it most recently. Okay, but currently you are using these apps. Okay, and similarly array of n-1 is the app which was least recently used. Okay, so this is the least recently used, that is this app was used much more ago. Okay, the task is to print the contents of the array when the user using the system presses Alt+Tab exactly k number of times. Okay, note that after pressing Alt+Tab key, app opening pointer will move through the apps from 0 index towards right. That is if you are pressing k number of times. Okay, so if you are pressing Alt+Tab key k number of times, so it will iterate from this 0 position to k position. That is suppose k equals to 3. Suppose k equals to 3. Okay, so if you are pressing k equals to 3 times, okay, so if you are pressing Alt+Tab key 3 times, then it will go to the position 4. Why it will go to the position 4? Because it starts from position 0. That means it will iterate from this left, and the position of this left is 0. So this is 0 position, this is 1, this is 2 and this is 3. Okay, and it will go to the position number 4. Okay, so that's an important point. And app opening pointer will move through the apps from 0 index towards right depending upon the number of presses. So the app on which the press ends, will shift to 0 index. That means, so this is an important point, see friends. So the app on which the press ends will shift to the 0 index. Okay, that means if you are pressed k number of times, that is suppose if you are pressing 3 number of times, so it will go to this 4 position and the ID of this position is 4 and this will shift to the 0 index. That means this 4 will come to this 0 index. Okay, and the rest of this will right shift. Okay, so because that will become the most recently app. So why it will come to this 0 position and rest of this will go, right? Because if you are pressing Alt plus tab key exactly k number of times, that means it will come to this position, and this ID, that is this apps, is the recent use apps, that is you are using these apps now, so this will come to this 0 position. That means it will become the currently used app. Okay, so that's why this 4 will come to here and the rest of the IDs will right shift. Okay, so this is the question, and here you can see, suppose this is the IDs. Okay, so 3 5 2 4 1, so this is 3, this is 5 2 4 1, and this is the IDs of the apps. So the ID of this first app, that is the currently used app, is 3. Okay, so you can say this is an ID or this is the name of the app. Okay, so then 5, then 2, then 4, and then 1. So if you press k number of times, suppose it comes to this 4, and this app, that is the number 4 app, will come to this first. Here is the output, that if you press k number of times, that is k equals to 3, so it will go to this 4 position and 4 will come to here. So here in the output you can see 4 comes first, that is this is the recent used app. Okay, then 3, then this 3, then this 5, then this 2, and then this 1. So here you can see this maintains the sequence. Okay, so this is the whole question, and I hope you understand this question. So how will you solve this question? So we have to calculate the position after k phrases. Okay, so let's write the code. And so first of all, write the basic format of the C++. So first of all, select here C++ body, and here write the basic format of the C++, that is as include. Okay, bits, then slash, then standard C++.h, and then using namespace standard. Okay, so first write the main function here. Okay, so inside this main function, what we'll write, we'll first write an array and k. Okay, so suppose the name of the array is a, and int a equals to, and here will be the elements. So what are the elements? So here's the element, so let's copy it from here. So 3 5 2 4 and 1. Okay, so let's copy it from here and paste it here. Okay, so after that we'll write the size of the array. So what is the size of the array? So for that, write an integer int n, and write a size of what? Size of a. So name of the array is a, so size of a divided by size of array 0. Okay, so size of array of 0. Okay, so this will calculate the size of the array. So next write the integer k. Okay, so the value of k equals to 3, so write it 3. Okay, so next we'll write a function. So suppose the name of the function is alt tab, so write here alt tab. So inside this first, this 3 variable, that is array a, and then the size of the array, that is n, and then the value k. Okay, so this is done, and next we'll write this function again. So before this main function, write this function again, and the return type will be what? Return type will be an integer, because here you can see in our output there is an array. Okay, array of integers, so we'll write here an integer because this will return integer value. So write an int, and then the name of the function, that is alt tab. Okay, so inside this function write the array, that is int a, and then int n, and then int k. Okay, so this is done, and so first initialize the index as 0. Suppose the index equals to 0. So now after k phrases, k number of phrases, we can calculate the index. So how can we calculate the index? So if you are given this k and this n, then you can easily calculate it. So index equals to k percentile n. So this will calculate the index after k phrases. So if you phrase k times, then this will calculate the index. So here you can see our size of the array, that is the value of n equals to 5. So here 5 elements, so the value of n is 5 and the value of k is 3. So after k phrases, what will be the index? So k equals to 3 here, then percentile, and then the size of the array, that is 5. So 3 percentile 5. So what will be the result? So 3 percentile 5 equals to 3, because 5 will not completely divided by 3, so the result will be 3, and 3 will be the index. So here you can see 0, 1, 2, 3. So after key phrases, your index will be here in these 4. Okay, so in this way we can easily calculate the index after key phrases. Okay, so this point is very important. Okay, so our next task is we'll store this index into another variable. So for that, write your index, and this will store the index. So this index will be stored into the x. So we are storing the index. So this is index 3. Okay, so what is the id, or what is the value, or what is the name of the x? So for that, what you can do, so using this array and this index, we can know the value of this id. So for that, write here int id equals to array of index. Okay, so index was 3 and a of 3. So here you can see a of 3 equals to 4, and this 4 will be stored into this id. So our id contains this 4, that is the value, and x contains this index. So the index of this is 3. Okay, so now our next task is we want to shift all of these elements, that is rest of these elements to the right, except this one, because after this 4 we don't want to right shift this, because if 4 comes to here, if 4 comes to this 0 position, then this 3, 5 and 2 will be go right side. Okay, so for that we'll right shift this 3, 5 and 2. Okay, and 4 will come to this 0 position. So 3 will come to here, 5 will come to here, and 2 will come to here, and we will not disturb this one. Okay, so for that we can write a while loop, and so write here while x greater than 0. So x is the position of this id, so the position of this id is 3. So if this position of this id is 3, before this element 4 there will be 3 elements. So the index of this id is 3, and before this there are 3 elements. So we'll write a while loop, and while x greater than 0. So while 3 greater than 0, we'll write this while loop. Okay, and we'll right shift these 3 values. So first, store this x into another variable. So suppose the name of the variable is phi. So in phi equals to x. So this x value will be stored into this phi. Okay, so now we'll decrease the value of x. So why we have decreased the value of x? So a of x will be stored into the a of phi. So now our phi value is 3. Okay, and we have decreased the x, so now our x value is 2. So now we can right shift it using these 2 values. So how? If we store the value of this position 2 into this position 3, then it will automatically right shift it. So for that we can write here array of phi equals to array of x. Okay, so array of x, that is array of 2. So array of 2 is what? So 0, 1, 2. So array of 2 equals to 2. So these 2 will be stored into the array of phi, that is array of phi. So array of phi equals to array of 3. So these 2 will be stored into this. So these 2 will come to here. Okay, so in this way we can right shift the elements. Okay, so after right shifting these 3 elements, we'll shift this 4 to the 0th position. Okay, so for that what you can do, a of 0 equals to id. So in our id this 4 was stored. So here this 4 is stored, and now we'll shift this id into the array of 0. Okay, so now we want to print the array. Okay, so for that write here for int I equals to 0, I less than a dot size, and then I plus plus. Okay, and this will print the array after doing this operation. So here you can see we are returning only an integer, but we are printing here the array. So how it will know that the array is changed or not? So for that write here asterisk. So if we write here this asterisk mark, then what we will do with this array A, so that will be effect to this array A here. Okay, so now we'll print the array. So to print the array, write here cout. So cout will print the array and array of I. Okay, so after printing every element, let's give a space here. Okay, so it's done. Okay, so let's run it. So there is an error in line number 8 and 15. So in line number 8, int id equals to a of index. Okay, let's remove this and run it again. So there is an error in line number 25 that request for member size in A. So line number 25. So here we can simply write A less than n. Why less than n? The size of the array is n. So for that we can write here A less than n. Okay, so let's run it again. So our output is 4, 3, 5, 2, 1. So after k number of phrases, so 4 will be come to this first position, and 4 here you can see 4 comes to the first position, and 3, 5, 2 will right shift by one position. So then 3, 5 and 2 and 1 will be in its initial position. So 1 is in its initial position. So this is perfect output. Okay friends, so hope you enjoyed this video. Believe me guys, this is a very easy question, and first we'll understand the problem and then we'll write the code. Okay, so here you can see, so here's the question. Bob has to send a secret code S to his boss. Okay, so Bob has to send a secret code S to his boss. He designs a method to encrypt the code using two key values, n and m. So n and m are the two key values. Okay, the formula that uses to develop the encrypted code is shown below. That is s to the power n percentile 10 whole to the power m percentile this number. Okay, so you have to write an algorithm to help Bob to encrypt this code. So how you will encrypt the code using this formula? Okay guys, so this problem seems to be difficult, but this is not difficult. This is a very easy question because the formula is given. You just have to write the formula into your code and you can easily encrypt the secret code. Okay, so how you will do this? So first you have to take the inputs from the user. So what inputs will you take from the user? This S, this N and this M. So these three inputs you have to take from the user. Okay, so you can see here friends, S, N and M, these are the variables. That is, you will be giving the inputs. So you can take the inputs from the user or the inputs may be given. Okay, so we'll take the inputs from the user and then we'll write the code. So first we'll do this operation S to the power n. How we'll do this? So using for function. We know the for function. If we want to do 2 to the power 3, then we can write here 2 and 3 and this will calculate the 2 to the power 3. So here we want to calculate s to the power n. So we have to write here s and then n. Okay, this will calculate s to the power n and we'll store this result into some another variable. Let's say answer, and after this we'll percentile this result by 10. So answer percentile 10. Okay, and we'll again store this into another variable, suppose answer. Okay, so after this we'll do answer to the power n, that is this whole to the power m. So you can see that this is inside a single bracket. So we'll do answer to the power m, and for that we'll use the for function here. So write the for function here, and after calculating this we'll store it into the variable answer. Okay, so answer will be updated every time. So now our answer contains this whole value. Okay, this whole value contains into the answer. Okay, so now we have to do answer percentile this bigger number. Okay, so for that write answer percentile this bigger number. That is, so how many zeros are there? 1 2 3 4 5 6 7 and 8. 8 zeros are there. So 1, then 8 zeros, 1 2 3 4 5 6 7 8, and then 7. Okay, so let's store the result into the answer. Okay, and finally we'll print the result. So right here print answer. Okay, so that's how we can do the whole operation and we can encrypt the code. So let's write the code. So we'll write the code using C language. So for that, write the basic format here, has include stdio.h, and then has include math.h. Okay, and then the main function int main. Okay, inside this main function take the inputs from the user. So for that we have to declare s, n and m here. That is, you can see here s, n and m, these three are unknown, so we have to take the inputs from the user. So first let's declare it, and the data type will be long int. Okay, so long int s, n and m, and we have to store the result into the answer. So let's write here answer. So now, so we can take the input from the user using scanf. Write %ld and then space %ld and then space and then %ld. Okay, and now write here ampersand s, then ampersand n and then ampersand m. Okay, so we have take the inputs from the user. So now our task is to calculate the power, that is s to the power n. So right here answer equals to power s comma n. So our next task is to answer %10, and we have to store it into the answer. So right here answer equals to answer %10. Okay, so our next task is, that is answer %m. Okay, let's do it. So answer equals to power answer to the power m. Okay, so now our next step is to answer % this bigger number. Okay, so let's copy it from here. Okay, let's copy the whole line from here and paste it here. Okay, and finally we want to print it. So write here printf, and inside this write %ld because this is long integer, and then write here answer. Okay, so let's run it. So we have to give some inputs here. So inputs will be s, n and m. So let's give some input here. So let's give 1 space 2 and space 3 and press enter. Okay, let's give here 3 inputs. Okay, 2, 3 and 4 and press enter, and you can see our encrypted code is 4096. Okay, this is the output and this is the encrypted code, and this is a very easy type question, but the question seems to be difficult and tough, but after writing the code you will feel that this is a very easy type question. How many times individual small a and capital A is present in string 2? So see friends, in your exam exactly this question may not come, but you have to know the concept of this question and you have to know how to approach the solution. Okay, so by doing this you will be able to solve similar types of question, or you can apply the same methods to the another question. Okay, so the main thing is that you should practice it more and more times. Okay, so my main motive is to boost up your confidence level so that you can solve any new questions or any types of questions. So if you are not able to solve it, at least you can try it by your own. So the question is jewels and stones problem. So why the name of the question is jewels and stones problem? So this is a story. So this is the real life scenario. But the main thing is that you will be given two strings and you have to find how many times this individual small a and capital A is present inside this string 2. Okay. So this is the main thing. But in the examination, you will see many types of scenarios based on real life. Okay. So here is also jewels and stones problem. So you are given a string jewels representing the types of stones that are jewels and stones representing the stones you have. So this is the stone string and this represents the stones that you have. Okay, each character in stones is a type of stone you have. So each character of the stones is the stones that you have. Okay, so each character is a stone. Okay, so you want to know how many of these stones you have are also jewels. So you know jewels are made from the stones. Okay, so you are giving stones and the jewels and you have to find how many jewels are present in these stones. Okay, so letters are case sensitive, so small a is considered as different type of stone from the capital A. So small a and capital A are different here. Okay, so there is also solution hint. So the solution hint is for each stone check if it is a jewel. So by using this solution hint, you can also try to solve this problem. So how we can solve this? So for each stone, check if it is a jewel or not. So this is stones. Okay, this string is a stones, but each character of the stones is a individual stone. So you have to check if each stone, that is this small a and this capital A and this capital A and this P. Okay, so if these characters is a jewel or not. So this is jewels and the individual character is a jewel. So this is small a is a jewel and capital is a another jewel. Okay, so in this way you can try to solve it by your own. Okay, so now let's try to solve it. So okay, let's see here. So we'll use the map concept here. So what is map? So map is a container which can contains the key and the values. Okay, so we can write the map like this map, and then inside this we can write the key and then the value. Okay, so suppose this is a map and here will be key and here will be value. Okay, so the key is A and its value is 10. So next the key is B and its value is 20. Next the key is C and its value is 30. Okay, so we can access this map value, that is 10, using this key A. Okay, similarly we can access this value 20 using this key B. So similarly we can access this 30 using this key C. Okay, so suppose the name of the map is MP. So you want to access this 30. So for that write here MPC. So C is the name of the key. So if you write here MP, then inside this write the name of the key, then it will access to this value of this key, that is 30. Okay, so we'll use this concept here, that is for this problem we'll use this concept. So how we'll use this concept? So here we are given two strings jewels and stones. So first we'll use a map, and in that map we'll iterate these strings, that is the jewel strings. Okay, and we'll check each and every character of this string and make its value as true. So here will be small a and here will be capital A. Okay, and when we are iterating we'll make this as true. Okay, so right here true. So similarly for this capital A also will write here true, that is the key will be small a and capital A and its value will be true. Okay, so now our next step will be we'll iterate this string, that is the stone string. Okay, So we'll iterate the second string and we'll iterate from the first to last, and we'll check in the map if the first character is present, that is if the first character is true or not. So if the first character is present, then we'll increase the count value. Next we'll check if the second character is present inside the map, that is if the second character is true. If it is true, then we will increase the count value. Similarly, we will do this for rest of the character. Okay, so in this way we can calculate the output. Okay, so this is our approach. Okay, so let's write the code. So first of all we'll write the basic format of the C++, that is #include, and inside this we'll write width, then standard C++.h. So why we are writing this bit standard C++.h? Because if we want to use the map or unordered map or some math function or some other boolean strings function, then we don't want to include the header files for each boolean function. Okay, and this bit /standard C++.h includes all the header files. So for the simplicity of the code, we'll write this because this contains all the header files. Okay, so for that we have right here bits /standard C++.h. Okay, so next write the using namespace standard. So first we'll write the main function. Okay, inside this main function there will be two strings. Okay, so string jewel and string stones. Okay, so right here string jewels, suppose J. Okay, and J contains small a and capital A. Next string is string stone. Okay, so string stone contains, you can see string stones contains this string. So let's copy it from here and paste it here. Okay, so now let's write a function. Suppose the name of the function is jewel in stone. Okay, J in S. Okay, so inside this we'll pass this J and this S. Okay, so now before this main function we'll write the same function again, and the return type will be integer because here you can see it will return an integer value. Okay, so for that we'll write here the return type as integer. So next write the name of the function, that is J in S. Okay, so here write the two strings, that is string J and string S. So string J comma string S. Okay, so inside this we'll write a map. While we'll write a map, because for the string J we'll iterate it and we'll make each character value as true. Okay, so each character will be the key and we will make it true. Okay, so for that character, so first will be character and then will be boolean, that is bool. Okay, so why the first will be character and the next will be bool? So here you can see we want the character, that is small a and capital B, as key value. Okay, so the first will be character because these are the characters, and the next will be true or false. So for that we have right here, so next will be true or false. So for that we have right here boolean. Okay, so this is the main thing. So next give the name of the map. So what is the name of the map? So you can give it anything. Suppose the name of the map is MP. Okay, now we'll write a for loop for iterating this J string. So for that write here for int I equals to 0. So for I equals to 0, I less than J dot size and then I plus plus. Okay, so inside this we'll iterate each character of the string J. So for that write here MP then J. So MP of J, that means here will be the string, that is J string. Okay, so J of what? So J of I. So why J of I? The string J will be here and it is 0 position, that is I will be 0 and then 1 and then 2 and so on. Okay, So j of 0, that is this j of 0, that is this position. Okay, so this position in the map will make it true. Okay, so this will be true. So similarly we'll do it for the next character, that is this will be 1, the I value will be 1. So j of 1 will be this capital A and MP of this capital A will be true. Okay, so we'll iterate this string and make each and every character value as true. Okay, so this is the first thing. And next we'll iterate this second string, that is this stone string, and we'll check if the value in the map, that is this map, if the value in this map is true for this particular character or not. Okay, so for that write a for loop here. For int I equals to, okay, int I equals to 0, I less than s dot size I plus plus. Okay, so inside this for loop we'll check MP of what? MP of s, that is we are going to check each character of this string s. So MP of s of what? S of this every character, that is the first character and then second. So for that we will write here s of I. So s of I means, so s is the name of the string, that is this string will come to here and then the first character of this string, that is I equals to 0. So s of 0, that is this a, small a will be here. So MP of small a is present. So for that we will write here if condition. If MP of small a is present, that is if its value is true. So if its value is true, then we'll increase our count value. So our count value will be increased. So in this way we can iterate all the string, and if this individual small a or capital A is present inside these stone strings, then we'll increase the count value. Okay, so we have not declare and initialize this count. So for that write here count, int count equals to 0, its initial value is 0. Okay, so finally we'll go outside of this for loop and we'll return this count value. So return count. Okay, so this will return the count value. Okay, so this is complete. So let's run it. Okay, there is no output. Okay, we have not write here cout. For that write here cout, and this will print the output to the screen. Okay, our output is 3 and this is perfect output. So here you can see our output was 3. Okay, so let's check it by giving another input like x, y and z. So x, y, z jewels is not present inside these stones, so it will show 0 output. So let's run it and see. So our output is 0, so this is perfect. Minimum number of sets with numbers less than y. So first let me show you the snapshot of the question which just came in the off-campus examination. Okay, so here you can see this is the wedding game, and here you can see the input output format with example and explanation. Okay, so here you can see this is the original question, but the same question came in the off-campus examination but with little change. So what change? So input output test case everything is fine, everything is same, but they have changed the scenario of the story. So here you can see the question is minimum number of sets with numbers less than y. Okay, this is the original question, but in the examination they have changed it to wedding game. Okay, so here you can see this is wedding game. So in the examination, if you find an unknown question, then don't panic, just read it carefully and try to understand what it is going to say. Okay, and maybe you have do that types of question previously, and you can apply that concept to that unknown question. Okay, so these two questions are same, and this is the original question. And first I will explain you the question, what it is going to say, and next we'll write the code. So you are given a string of consecutive digits and a number y. So here you can see you are given a string with consecutive digits. So 1, 2, 3, 4, these are consecutive digits. Okay, and a number y. So this is an integer number y. So you will be given this. The task is to find the number of minimum sets such that every set follows the below rules. So you have to find the number of minimum sets such that every set follows these three rules. So what are the rules? The set should contain the consecutive numbers. No digit can be used more than one. So you cannot use one digit more than one time. Okay, and set should contain consecutive numbers, and you should maintain this consecutive number set. Okay, and the third rule is the number in the set should not be more than y, and the number formed by this should not be more than this y. Okay, so this is the original question, and if you tally this question with this waiting game question, then you can see here. Okay, let's zoom it. So in a wedding that you are attending, there are some chairs that have digits inscribed at their backs. So you are attending a wedding and there are some chairs, and in the back of the chairs there are some digits. Okay, the chairs are lined in a row such that they form a string of digits. So the chairs are lined in a row. So all the chairs are lined in a row and they form a string of digits. Okay, so you have to find the minimum number of sets M that can be formed from these digits such that these are the condition. Okay, such that the number of digits in each set is 1 or more than 1. Each set is formed using consecutive digits and no digit can be used more than 1. You can see each set is formed using consecutive digits. Okay, so there will be consecutive digits and no digit can be used more than 1. So you cannot use one digit more than one times. Okay, and in each set the number formed using digits is less than or equal to this y. Okay, so less than or equal to this y. Okay, so these two questions are same, but the story is different. Okay, so input output everything is fine. Okay, so now our string is 1 2 3 4 and y is 30 and our output is 3. So how the output will be 3? So see here friends, the task is to find the number of minimum sets such that every set follows these rules. Okay, so you have to find the minimum number of sets. So how can you find the minimum number of sets? Okay, so this is the string. We have to find such sets that follows these three rules. Okay, we can write this 1 2 then 3 and then 4. So this could be one set. Why? Because this satisfies these three conditions. So set should contain consecutive numbers. Yes, this contains the consecutive numbers 1 2 3 4. No digit can be used more than 1. So no digit is used more than one time. Okay, the number in the set should not be more than y. So the numbers are 12, 3 and 4, and these are not more than this 30, that is this y. Okay, so this is set 1, and there could be another set like this 1, 23 and 4. So this also satisfy these three conditions. So this would be a set. Okay, so your task is to find the number of minimum sets such that every set follows the below rule. So how many sets will be there that satisfy these three conditions? So we have find these two sets. So 1 2 then 3 4. So this will not satisfy this condition because 34 is greater than this 30. Okay, so this will not be our expected set. Okay, so let's remove this. So let's write 1, 2, 3 and 4. Okay, so 1, 2, 3, 4, this satisfies these three conditions, and I think no other sets is possible using these numbers and these rules. Okay, so you have to find the minimum sets. Okay, so you have to find the minimum sets. So these are the minimum sets. Okay, so our output will be 3. Okay, so hope you understand this question. So now we'll write the code. Okay, so before going to the solution, make sure you have subscribed to this channel, because this will be helpful for your upcoming examinations. Okay, so not only for a particular examination, so this will be helpful for your many coding test examination. So please subscribe this channel and press the bell icon, because when I will upload a new video, you will get the notification first. Okay, and if you like my video, then please give a like and share it with your friends. Okay friends, so let's write the code here. Okay, so we'll write the code using C++. So first of all, write the basic format of the C++, that is as include with standard C++.h using namespace standard int main. So in the main function, what we'll write? We'll write a string. So here you can see our input is a string and an integer. Okay, so for that we'll write here a string. So string s equals to 1, 2, 3 and 4. Okay, this is the string. And what is the size of the string? Suppose the length of the string is L. Okay, so int L equals to s dot size. Okay, so this is the length of the or size of the string. Okay, so here will be s dot, and next there is a integer y and it is 30. Okay, so next I'll write a function where we'll do the operation. So the name of the function is suppose waiting game, and right here waiting game. So inside this, first these three variable. So inside this, right here s and then y and then l. Okay, so we'll write the same function before this main function. So the return type will be integer, because it will return an integer value, because here you can see it will return an integer value. Okay, so for that we'll write here int, and then the name of the function waiting game. So inside this, write string s and then int y and then int l. Okay, so inside this write a for loop to iterate through the string s. So for that, write here for int I equals to 0, I less than l and I plus plus. Okay, so this for loop is for iterating through the string s from 0 to less than l. So before this for loop, write a variable, suppose int num. So where we'll store the digit. So num, our initial num value is 0. Okay, so here will be num equals to num into 10. So why num into 10? So I will tell you. So next write here s of I minus 0. So our input string was 1, 2, 3 and 4. So this is a string, and here int, here num is an integer. Okay, so initial num value is 0. So here for I equals to 0, num will be 0. So 0 into 10 will be 0, and s of I equals to 1. Okay, so 1 minus this 0 will be 1. Okay, and that will be a number. Okay, so 0 plus 1 will be 1, and in the num there will be 1. So now we will write a condition. So what was our condition? So here you can see our condition was the number in the set should not be more than y. Okay, so the number in the set, that is 12, 3, 4, this should not be more than this y. Okay, so the number should be less than or equals to y. So for that we will write this condition here. If the number is less than or equals to y, then suppose there will be a flag, and flag will be, so write here the flag. Suppose our initial flag is, suppose this is flag and initial flag is suppose 0. Okay, so if we find that if num is less than equals to y, then our flag will be 1 because the condition has been satisfied and the flag will be 1. So we can know that when the flag will be 1, that means this condition satisfied. Okay, so for that we have write here flag equals to 1. Okay, so else what? Else we'll check if flag equals to 0 or 1. So we don't know if flag equals to 1 or 0. Okay, so for that write here if flag, that is if flag equals to true. So if you write here if and then flag means if this is true, then this if condition will be satisfied. Okay, and if this is false, that is if this is 0, then this if condition will not satisfied. So if you write if and then inside this bracket only this variable, then that means if flag equals to 1. Okay, so instead of this I have write only if flag. Okay, so you can also write this. So if flag, then we'll increase our count value. Count equals to count plus 1. Okay, so let's initialize the count value. Int count equals to 0. So our initial count value equals to 0. Okay, so now the num value will be what? So num value will be s of I minus 0. So if this if condition not satisfied, then we will go to this else condition, and if flag equals to true, then the count value will be increased and num equals to s of I minus 0. Okay, so that will be the num and flag will be 0. So why the flag will be 0? Because the condition is not matched. So we have write here flag equals to 0. So you can say that our initial flag value was 0. Why will write here 0? Because after every iteration we'll check again if this condition satisfied or not. Okay, so after every iteration the flag value may be 1. So here's difference. So if num is less than equals to y, then we'll write here flag equals to 1, else num equals to 0. So if this condition satisfied, then the flag will be 1 here. Okay, so if the flag is 1 here, so when it will go to the next iteration, and if this condition not satisfied and if it comes to here, then the flag will be 1. So we want to make this flag equals to 0 here. So for that we have write flag equals to 0 here. Okay, so for more simplicity we'll dry run this program, that is we'll check using this example. Okay, so for I equals to 0, our num equals to num will be 1. So why num will be 1? Because our initial num was 0. So 0 into 10 equals to 0 and s of I minus 0. So s of I was, s of I was this 1 and 1 minus 0 equals to 1. So 1 plus this 0, that is 1. So our num is 1. Okay, now we'll check if num is less than equals to y. So num is 1 and our y is, so what is our y? Our y is 30. So if 1 is less than 30, so yes, 1 is less than 30, then our flag value will be 1. Okay, so let's write here. So for I equals to 0, we are checking it for I equals to 0. Okay, so for I equals to 0, so this condition satisfied, that is num equals to 1 and y equals to 30 and 1 less than equals to 30 and this is 2. So our flag value will be 1. So for I equals to 1, our flag value will be 1 here. Okay, so we will not go to this else condition because this if condition satisfied. Okay, so we'll increase our I value and we'll go inside this, and now our num will be num into 10. So our previous num was 1, so 1 into 10, that is 10. So this will be 10 plus s of I minus 0. So s of I equals to now 2. So 2 minus 0 equals to 2. So 10 plus 2 equals to 12. Okay, so now we'll check if 12 is less than equals to 30. Yes, 12 is less than equals to 30. So now flag will be 1. So here for I equals to 1, our flag will be 1. Okay, So as this if condition satisfied, we will not go to this else condition. Okay, so now we'll increase the I value and again we'll go inside of this for loop, and now our num will be, so our previous num was 12 and 12 into 10, that is 120. So 120 plus s of I minus 0, so s of I equals to 3, so 3 minus 0, that is 3. So 120 plus 3, that is 123. So now we'll check the condition. If num less than equals to y, that is 123 is less than equals to 30, no, this is false, so we'll go to this else condition. So if flag equals to true, yes, flag equals to true. Why? Because our previous flag was 1. Okay, so we'll increase the count value. So our initial count value was 0, so now we'll increase the count value, and this will be for I equals to 2. So for I equals to 2, our count will be 1. Okay, so count increase. So our num will be s of I minus 0. So what is s of I? So s of I is now 3. So 3 minus 0, that is 3. So our new num will be 3. Okay, so flag will be 0. So let's write here num equals to 3 and flag 1. So our previous flag was 1 and now it will be 0. So you can see here we have done flag equals to 0 here. Okay, so flag will be 0. Now we'll check the condition. If num is less than equals to y, so now our num is 3 and 3 is less than equals to 30. Yes, 3 is less than 30, so flag will be 1. So now the flag will be changes to 0 to 1. Okay, so this else condition will not execute, and we'll go to this for loop and I will be increased, and we'll see for I equals to 3. So let's write here for I equals to 3. So for I equals to 3, we'll calculate the num. So our previous num was 3. So here you can see our previous num was 3. Okay, so 3 into 10, that will be 30. 30 plus s of I minus 0. So s of I equals to now 4. So 4 minus 0 equals to 4. So 30 plus 4, that is 34. So num is now 34. So if 34 is less than equals to y, no, this is false. So we'll go to this else condition. So if flag, that is if flag equals to true, so our flag was 1, yes, flag equals to true. Okay, so if flag equals to true, then we'll increase the count value. So our previous count value was 1 and our new count value will be 2. So count will be 2. Okay, so our new count value will be 2. So now we'll calculate the num, that is our new num will be s of I minus 0. So s of I now equals to 4. So 4 minus 0, that is our new num will be 4. So you can see our previous num was 3 and that will be replaced by this 4. Okay, so our new num value will be 4. So let's write here num equals to 4. Okay, so num equals to 4. So now the flag will be 0. So let's do flag equals to 0 here. Okay, so now we'll check if num is less than equals to y, that is our new num value is 4. This 4 is less than equals to 30. Yes, 4 is less than 30, this is true, and flag will be 1, and this flag will changes to 1. Okay, so we have iterated all the characters of the string and the for loop will be terminated, that is we'll go outside of this for loop. Okay, so for loop ends here. So you can see for loop ends here. Now we'll check here if our flag is 1 or 0. So if flag, that means if flag equals to true. Okay, so if flag equals to true, then we'll increase the count value. So count will be count plus 1. Okay, so finally we'll return this count. So return count. Okay, so see here friends, after go outside of this for loop, we'll check if flag, that is if flag equals to true. So our final flag was, that is our last flag was 1. So yes, flag is 1. Okay, that is flag is true. So the count value will be increased. So now our final count value will be 3. So why 3? because the previous count value was 2 and it will be increased by 1, so our final count value will be 3. Okay, so we'll return this 3, so this 3 will be returned. So for that we have right here return type integer. Okay, so this integer value will be returned to this main function because we have called this function from this main function. So we want to print this, so for that right here cout. So our code is complete, so let's run it. Okay, there is an error in line number 20, flag was not declared in this scope. Okay, so line number 20, let's see. Okay, spelling mistake, it's my bad. Okay, so let's run it again. Okay, it's completed successfully and our output is perfect, 3. Okay, so this was our expected output. So today we'll discuss about the count the number of consistent string. So first of all we have to know what is consistent string. Okay, so let's see the question. So you are given a string allowed consisting of distinct characters. You are given a string allowed. So here you can see in the input you are given a string allowed consisting of distinct characters. So distinct character means unique character. So in the string allowed you can see all the characters in the strings are distinct, that means unique characters. So no repeating characters will be there in the string allowed. Okay, so you are also given an array of strings. So now the main thing is that consistent. So a string is consistent if all characters in the string appears in the string allowed. That means you are given a string allowed and it contains only unique characters. Okay, so you have to find the word inside this words array, okay, which contains this A and V. Okay, so here you can see the first string, the first word contains A and D, so this will not be counted. That is, this is not consistent string. So next is V and D. So B and D is not present here. So here you can see A and V. That is 3 small a and then a V. But here you can see this is A and V. But this string contains only A and V. Okay. So if the string contains only this character, only this A and V. So here you can see there is no other character except A and B. So if it contains only these characters, that is A and B, then it will be counted. So this is a consistent string and this will be counted. Okay, so now see here VAA. So VAA contains this A and V. So here only A and B are present and no other characters are present. So this string also be counted. Now our next string is BADAV. So here you can see B and A are present. Okay, so in our allowed string there was A and V. So here also A and B are present, but there is extra character, that is D is also present. So this will not be counted and this is not consistent string. Okay, so here is only two consistent string, that is this one and this one. So our output will be 2. Okay, so you have to return the number of consistent string in the array words. So from this array words you have to return the consistent strings, and here the consistent string is 2, so we will return 2. Okay, there is also solution hint and you should try to solve it by your own. A string is incorrect if it contains a character that is not allowed. So if a string contains a character that is not allowed, then that string will be incorrect. Okay, and that will be not counted. Okay, so now how we will solve this? Here in this problem only the small letters are present, no capital letters are present. Okay, only the small letters are present. So for that what we can do, we can make an array of length 26 and inside the array, and inside that array what we will store, we will iterate this allowed string, and every character position will be stored into the array, into that array. That is, we will not store the position. If this A is present, then the position 0 will be true. If V is present, then the position B will be true inside the array. Okay, so our first task will be to create an array and iterate this string. So our first task is create an array of length 26 and check if character in allowed is present, and check if character in allowed is present, then make it true. Okay, that is, make that position true. Okay, and our next task is we'll iterate through this array, that is array of strings, and we'll extract every string and we'll check every character, and inside the every character we'll check if that character's position is true or false inside the array which we have created. If this is true, then we'll count it. Okay, so let's do the code and you will better understand it. So first, write the basic format of the C++, that is as include with standard C++ .h. So why we have write here bit / standard C++ .h? Because we don't want to include each and every header file. So for that we are writing here bit / standard C++ .h, and this contains all the header files. Okay, so we don't have to write each and every header file separately. So next, write the using namespace standard, and first write the main function, that is int main, and inside this main function what we will write, we'll write string, that is here you can see allowed string and a word string. Okay, so there will be string s, suppose the name of the string is s and this is allowed string. Okay, and it contains ab. Okay, so this is allowed string. So next we'll write a string. No, we will not write a string. So this is not a string, this is an array of string. So how will I write this? So for that we can use a vector. Okay, so inside a vector we can store each and every word. Okay, so if you want to know more about the vector in C++, then please see my vector videos which I have made, and in that video I have explained the vector in a very simple way, and you will get a minimum idea how to use the vectors. Okay, so the link of that video will be in the description below. Okay, so let's create a vector, and inside that vector we'll store this. Okay, so how to create a vector? So for that, write here vector. So first write here vector and then the data type. So what data types will be? So these are the strings, so the data type will be string. So for that write here string. So this is the data type of the vector. So the vector will store the string type data. Okay, so next, the name of the vector. So what is the name of the vector? Suppose the name of the vector is what, that is w. Okay, suppose this is the name of the vector. Okay, so it's done, and now we want to store these values, that is store all of these values inside the vector. So for that, let's copy it from here, write here a curly braces, and inside this paste it here. Okay, so remove this. Okay, so now the vector w contains these strings. Okay, so now our next task is to create a function where we'll do all the operations. So suppose the name of the function is count string. Okay, so inside this write this s and w, because we want to first these two. So s and w. Okay, so it's done. So now let's write the function again, and its return type will be integer. Why? because it's return an integer value. Okay, so for that write here int and then the name of the function, that is count string. So inside this what we will write, so we have what s first. Okay, so for that write here string s. Okay, next what do we have first? Next we have first a vector. So for that write here the vector, that is vector, and then its data type, then write here ampersand and then the name of the vector, that is w. Okay, now inside this first we want to count how many strings, that is how many words are present inside this vector. Write your int count and it will count the size of the vector. So for that write your name of the vector w and then size. Okay, and this count will contains the size of the vector, that is 1 2 3 4 and 5. So this will contain 5. Okay, now we'll write an array and its data type will be boolean because we want to store true or false inside this array. Suppose the name of the array is a. Okay, so inside this write the size of the array is 26. Why the size of the array is 26? Because there are 26 characters and all are the small characters. Okay, so for that we have write here 26 and let's initialize it with false. So all of this position of this array will be false. So now we'll write a for each loop. So what is for each loop? So suppose you have this arrays. So in the for each loop it will extract every string from this array and it will execute it. Okay, so how can we write this for each loop? So first of all write the data type. So suppose character and then C and then from where you want to extract the data. So we want to extract the data from S. Okay, that is from this string S. Okay, so from this string S first A will be extract to this S and A will be passed to this C. Okay, so we'll do the operation with the C. Next after doing the operation B will be passed to this S and S will pass this B to this C and we'll do the operation with B. Okay, so in this way we can use this for each loop. And this is character because in this string we are extracting every character. Okay, so for that we have write here character. Okay, so after extracting every character from this string we are going to make its position is true or false. Okay, so for that inside this for loop let's write the name of the array and then C minus A. So why C minus A? So C contains a character, so it contains this A. Okay, so A minus A will be 0, so A of 0. So in the array of 0 position will make this position true. Okay, so similarly next B will come to this S and B will pass to this C and B minus A will be 1. So A of 1 will be true. Okay, so in this way this for loop will execute. So similarly we'll write this for each loop for the vector W. Okay, so for that and then we want to extract every string. So write here string and then the name of the string is suppose str. Okay, then write here colon and from where you want to extract. So from W we want to extract. Okay, so write a W. Okay, so inside this for each loop write another for each loop. Suppose for character C colon str. See here friends, from this vector we are extracting every string, this string, this string and this string, and this string will come to this str. Okay, so when it will come to this str it will go inside of this for each loop and here in this str this string will be there, that is AD will be there, and from this string using this for each loop we are extracting every character. So for that we have write here character C. So from this AD, so A will come to this C and next D will come to this C. So in this way this whole for each loop will work. Okay, so for every character the string will check if array of C minus character A is equals to false. If this is false, that is if this character, if this A or D is not present inside this string, then we will make it false. Okay, so then we will decrease the count value, that is that string will not be counted. So let's decrease the count value, so count minus minus, and when we are decreasing this count value, then we will go to the next string. So for that we will go outside of this for each loop. So how can you go outside of this for each loop? So just writing a break. So if you are writing a break, that means you are not executing anything after this. Okay, so you will go outside of this for each loop. Okay, so next we will check this string and every character of this string. So similarly we'll check the next string and the next and the next. Okay, so after that finally we'll go outside of this for each loop and return the count value. So why will return the count value? Our initial count value was the size of the array. So our initial count value was 5 and any character is not present inside this allowed, that will not be counted and the count value will be decreased. So here you can see D is not present inside this, so this will not be counted, that is count will be decreased. So our count is 5 and the count will be decreased to 4, and next B is present, D is not present, so count will decrease and count will be 3. Next AB is present, okay, count will not be decreased, count is 3 now. So BA is present, so count will not be decreased, count will be 3 now. Here you can see BA is present but D is not present, so count will be decreased to 3 to 2. Okay, so our final count value will be 2 and it will return 2 from here and it will come to the main function. Okay, we'll print it. So write here cout and print it from here. Okay, so it's done. So let's run it. So it gives 5, but this is not the expected output. Okay, so let's see what is the mistake. Okay, after this if condition we have not give any curly braces. Okay, so for that give your curly braces, and here also after this break. Okay, so it's done. Let's run it again. So our output is 2 and this is the perfect output and this is our expected output. Okay, so here you can see our output was 2. Okay, so in this way you can check it by giving another inputs. A valid parenthesis sequence is a non-empty string where each character is either this first bracket or this, either this opening brackets or this closing bracket. Okay, so we satisfy the following constant. So here is the constant. You can find a way to repeat erasing adjacent pairs of parentheses until it becomes empty. Okay, so for example here you can see this and these two are the valid parenthesis sequence, but here these two are not the valid parentheses. So if you see in the input, here is some parentheses, opening and closing parentheses. So after removing these first two parentheses and these two parentheses, you can see our output will looks like this. So you have to show an output in such a way that there will be the opening brackets. So for the first there will be some opening brackets and after that there will be same number of closing bracket. The ASCII value of the opening bracket of this first bracket is 40 and the ASCII value of this closing bracket is 41. Okay, so using this ASCII value we can easily do this task. Okay, so for that we will write the code. Okay, so first of all write the basic format of the C++, bits, then slash standard C++.h, then using namespace standard. Okay, so first of all write the main function here. So first write here the main function in main, and inside this main function take a string, because here you can see this is a string and we have to return a string. Okay, so in the main function first we'll take a string from the user. Okay, so for that write a string. So suppose the name of the string is s and input it from the user, so for that scene s. Okay, so now write a for loop to iterate through the string. So for that write a for loop here for int I equals to 0, I less than n. So what is n? N is the length or size of the string. So for that you have to get the size of the string, that is int n equals to s dot size. Okay, so for int I equals to 0, I less than n and I plus plus. Okay, so inside this for loop what we'll do, we'll check if this is a opening bracket or closing bracket. So how we'll check this? We can check this using the ASCII character, that is 40 or 41. Okay, so for that we'll check here if s of I equals to 40. If this is 40, that means if this is a opening bracket, then we'll increase the value of a variable. Suppose our count value is 0, so int count equals to 0. So this is the initial value of count. Okay, so next if this is a opening bracket, then we'll increase this count value. So for that write here C++. Okay, else what we'll do, else we'll decrease this count value. So for that write else C minus minus. Okay, so now we'll check for every I value the count will be stored into this C, and after that, so after every iteration we'll check. So after every iteration we'll check if this count value is the maximum value or not. So for that we have to count the total maximum value. So for that write here another integer, that is int t. So this is for total. Okay, now we'll check which is maximum, t or c. Okay, total or count, so which is maximum? So if t is maximum or c is maximum, we'll store it into the variable t. Okay, just store it into the t. Finally, after iterating whole the string, t will contains the length, the maximum length of the opening bracket or closing bracket. So here you can see after iterating whole of the string, the t will contain the maximum, that is if there is a maximum 3 opening bracket, the t will contain 3, and if there is maximum 3 closing bracket, it will also contain 3. Okay, so now we'll print the output. So how you print the output? So for that write a for loop and for int I equals to 0, I less than what? I less than t, because we want to print t number of brackets. Okay, so for that write a t and increase the I value, and inside this print. So what do we want to print? We want to print this opening bracket first. If there are t numbers of opening brackets, then we want to print the t numbers of opening bracket, then we'll print the t numbers of closing bracket. Okay, so our first task is to print these 3 numbers of opening bracket. Okay, so for that we will write a for loop and for int I equals to 0, I less than t, I plus plus, and here we'll print, that is to print write here cout, and we want to print the opening bracket, and the ASCII value of the opening bracket is 40. So we want to convert it into character. Okay, so we don't want to print it into ASCII. So write here character and then 40. So 40 will be converted into character, that is the opening bracket. Okay, and it will print. So if there are 3 opening bracket, then it will print 3 opening bracket, and after this there will be 3 closing bracket also. So for that we'll write another for loop. Okay, so for that after this write a for loop, that is for int I equals to 0, I less than t, I plus plus. Okay, so inside this write the same thing, but we want to print here the closing bracket, and the ASCII value of the closing bracket is 41. So for that write here cout and character 41. Okay, so this is done and let's run it. So it's run successfully, and here you can see our input is this. So we have to give this input. Okay. So here you can see this is perfect output. So our output was like this. Here in this code you can see this is the perfect output. Okay, so this is the whole code, and you can check it by giving the another test cases. Find all the roots of this quadratic equation. So here a, b, c, these are integers, and x is variables here. So we'll find the roots of this equation. Okay, so you know the formula how to calculate the roots of this equation. Okay, for that there is a formula like this: x equals to minus b plus minus root over b square minus 4ac by 2ac. So this is the formula. Using this formula we can easily calculate the roots of this quadratic equation. There will be two roots, and these two roots will maybe equal, this may be complex roots. Okay, so b square minus 4ac. So your roots will be real or complex. This depends on this b square minus 4ac. So if this greater than 0, so if this part is greater than 0, then your roots are real. Okay, if b square minus 4ac becomes 0, then your roots are equal. And if this b square minus 4ac is less than 0, that is if this is negative, then there will be complex roots. Okay, so in this way you can calculate the roots of this equation, and you can easily find if your roots are real, or your roots are equal, or your roots are complex. So let's say b square minus 4ac is equals to d. So now there will be three conditions. So if d is greater than 0, then we'll find two roots, r1 and r2. Okay, and these roots will be real. Else if d is 0, then we will also get two roots, and these two roots will be equal. Else there will be the complex roots. Okay, so in this way we can calculate the roots of this quadratic equation, and for that we need some inputs like a, b, c. We need these inputs from the user. Okay, so using this formula and this condition, these three conditions, let's write the code. Okay, first of all write the basic format of the C++, that is has include IOStream using namespace standard, and then write the main function, and inside this main function we'll write the variable like double, and then a, v, and then c, and then d. So let's take inputs from the user, that is a, v, and c. So let's take these three inputs from the user, and then d equals to b square minus 4ac. So b into b minus 4 into a into c. Okay, so now we'll check if this d is greater than 0 or less than 0 or equals to 0. Okay, if this is greater than 0, then there will be two roots, r1 and r2, and r1 will be minus b plus square root sq over t, and inside this d, that is minus b plus square root of b square minus 4ac divided by twice a, 2 into a. Similarly r2 will be minus b minus square root of d by twice a. So here will be plus and here will be minus. Okay, and finally we'll write the output here, cout r1, and give some space here, and then r2. So these are the two roots if d greater than 0. So write this inside this curly bracket. So else if d equals to 0, then if d becomes 0, then r1 and r2 will be same. So here you can see if d becomes 0, so this is the d b square minus 4ac. So if this becomes 0, then our result will be minus b by twice a. Okay, so write it here. So r1 equals to r2, so these two will be same, and this will be minus b by twice a. So 2 into a, and cout will be r1. So r1 and r2 both are the same, so we'll just output the one result. Okay, r1 or r2. So else this will be the complex. So r equals to minus b y 2 into a, and this is the real part, and our imaginary part will be square root of minus d by twice a, minus d by twice a. Okay, so this will be the real part and this will be the imaginary part, because you can see here, so this is minus b by twice a, so this is real part, but inside this root you can see here b square minus 4ac, so this is negative. So if b square minus 4ac is less than 0, then this will be the complex root, and b square minus 4ac is negative, that means root over of some negative numbers will become imaginary numbers. Okay, so right here cout, and we want to output the complex root. So our complex roots will be r plus I, and then space, and then minus r plus I. Okay, so you can write here r plus I also. So let's run this program, and before run this program we have not declared this r1, r2 and r and I. So let's declare it here, r1 and r2 and r and I. So let's run this. Okay, square root was not declared. Okay, let's remove this equal sign and include the math file here. So let's include math.h. Okay, so let's write it again. Okay, so give some inputs here, and the input will be a, b, c. So here you can see x square plus bx plus c. So we have to give these three inputs a, b and c. Okay, so let's suppose this is 2x square, and this is minus 8x, and this is 3. So 2x square minus 8x plus 3 equals to 0, and we want to calculate the roots of this equation. So a, b, c becomes 2, minus 8 and 3. So let's give it here, 2, then minus 8, and then 3. Press enter. So you can see these two are the real roots, and these two are unequal, and this is double type. So we have write all the things in double, so the result is in double type. Okay, so in this way you can find the roots of a quadratic equation. So you can check by giving another inputs of a, b and c.